So hello, what we did till then was that we tried to discuss how actually adding two numbers with the digits separated is quite hard. Like it's it's a bit hard to actually simulate the addition system. Like I'm not talking about those 2-bit addition like half adder, full adder or all those stuff, but seriously, it's a bit hard actually. Uh, so how can we simulate this? How can we simulate addition? So this is the actual question. How can we simulate addition? First of all, what should we do? The problem is that I have taken two random numbers. I took two random numbers. So while doing this calculation, we all saw that 5 plus 9 is 14. 4 carry 1, 1 plus 5 plus 2 is 8, and then 2 plus 3 is 5, and then 3 plus 5 something I think I have okay, fine, okay, fine. uh, so what do we do is that actually they are actually while doing this addition, the main challenges are, what are those challenges? First of all, we have to face carryovers. Okay, carryovers. Okay, good. Now, second of all, we will have to face LLs. LLs are a bit of a hassle. Okay, fine. And number three, what is number three? Basically, 9 plus 5. And the process of addition itself. What should be the like 35807? Oh, this should also be in reverse. Okay, my goodness, where are we going? If okay, while at least making this, we need to make it a bit okay. Yeah, understandable. But how? Actually, is it? I have no idea. This is a single list. Oh my goodness, that is just So awful actually. Uh, okay. That is. Ah. 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 Hmm. Range from 1 to 100. When it ranges from 1 to 100, when it is in 100, it will be a lot bigger. The challenges will be a lot. We need to first of all, like, if we go towards the end of the list, then it's game over. What do we need to do? We need to start from the back. We need to start from the back. We need to start from the back. How can we start from the back? Basically, how can we start from the back? Actually, how can we start from the back? So there is a thing that's called like, for example, first of all, we'll have to add like, for example, there is 5 and 2. Okay, good morning, good morning, good evening, good evening, good afternoon, good afternoon. So what will we do is, oh my goodness, how will we do this? How will we do this? This is struct list node is a, we will also have to make a simply linked list. So we have no way to know how we will be able to it is just gain more memory space. Sometimes it is you know what, sometimes it is in uh, discussion is very important for this one. No, most votes. Most votes is actually fine. How to solve? No, not beginner friendly. Actually, uh, 1 1 2, 1 2, 1 2 3. Okay, okay, okay. Add two numbers. What are they trying to do? Okay, list node new head is 0. List node new head 0. What does it mean? Oh, this is C plus. What does it really mean when they are talking about list node new head 0? 0. What does 0 mean here? I haven't done data structures in C++, only in C. While C or L1 or L2, I think they are trying to refer to if some one of them is not a 0, then what will happen? C plus equals to L1 question L1 to L1, like L1's we will be taking the value of L1 and or it will be 0. That is a normal ternary operator thing. So one we will take the val, otherwise 0. Wait, what is this? What am I looking at actually? While none of them is 0, oh, they have taken a separate variable for carry forward as I have envisioned. So L1 and L2 are there. So C plus equals to L1 question mark L1 to val. What is C trying to do? C plus equals to L1 to val. L1 to val. Okay. This requires lots of maths more than anything. This is not exactly an efficiency problem, or it is indeed, but how? This is not even an efficiency problem. This is actually how you will be able to manage this. What they are trying to do, for example, is that we will have to, basically what will we have to do? We will have to go from this to this basically. Hmm. Okay. Actually, we will have to go from left to right instead of being going from right to left like we usually do while adding. So what is that? Actually, 1, 4 plus is 7, 5 plus 0. Okay, fine. What is 5 plus 0? I have no idea what is 5 plus 0. 5 plus 0 is 5. So 5 plus 9, 14. We got a 14. But we have already crossed that. Wait. Something really tells me that we will be able to do this. Take a deep breath. Take a deep breath. Okay. So what is out there? We will be facing stuff like this. Oh no. Oh no. 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 We will. Let me just draw. These are just very bad circles. Okay. Hmm. Beautiful. So what will we do? No, this is not even. Get the shift correction done. Okay. Now, no, that didn't happen. That is just so hard. Ha! So, what are we trying to do? We are trying to do, first of all, this. What is this? Yes, good. And then this. Okay, this is a. These are two LLs. Okay. Oh my goodness, no. And this. My pardon my drawing, but still, that you will understand what we mean by this. 5. Okay, no, not the best font, not the best color possible. 5. Okay, so 5 and then 2 we have in the first one, and what we will have in the second one, we have 9 and then 2 and then 3. Oh no, and then uh, where is it, 3, and it goes on like this, this literally goes on and on. Okay, okay, fine, beautiful. So basically what we are going, oh, this is a this is a simple after addition. Let us simply write them. After visualizing the problem, we got the answer. We didn't even have to look at what was out there. We didn't even have to look at that. So what we are going to do is that, first of all, what will we do? What will we do? First of all, we will try to, why, no, not that, You are doing something, no. And, wait. Let us call a new node. Let us create a new node. List node, struct list node, basically struct list node. Struct list node hasn't been said as per, like, it hasn't been written, like nothing is written here like the LL node or something like that. Nothing is actually written here, so otherwise we would have always given LL node. Otherwise we would have given LL node star. Okay, so still we will make something struct ll. What will be, we will allocate some space for struct element. Okay, we will allocate some space for struct element. What is space? What is space? We will actually allocate what, how to allocate space, how to allocate space, my friend. We will use malloc size of and this. Okay, fine. How to use space? Okay, struct list node. Ha ha ha. Very beautiful. Mm-hmm. Ah, struct list of what? L1 or L2 or what? L3. What did I make it? L3. Malloc. What will be malloc? Malloc. What is that? Something malloc. Memory alloc. Okay. Size of. Then what? Struct this node. This is beautiful. This is beautiful. This is legendary. Okay, you all know that this is legendary, but what does it define? Java. Okay, this is also legendary. We will declare the constructor, I guess. I think. Uh, First of all, okay, I think I got the. I will be making it in Java soon. Not right now, but after a few minutes, I guess. Okay, so we have made it. Now, what to give? We have already allocated the new memory location into L3. If we just give it a star and dereference it, we will get L3. We will get the location of L3. It will be represented by the hex code. Okay, fine. But what will we do next? We will have to do malloc, size of struct, this node, and beautiful. Okay, so what will we do? First of all, let's take the list node. Second, what will we do? What will we do? I'm in a bad. I forget everything, I guess. Okay, what will we do? What will we actually do? After allocating, then we will just start to. Okay, carry C. C is fine, actually, So what gonna happen? What will happen? What will happen? What will happen? What will happen? So while C is not equals to null, while what? While what? C, not C. The pointer of L3 doesn't point towards. No, the pointer of L1. I'll C or L1 or L2. What is this? I have no idea what they are cooking up in their minds. So while list.next is not equals to null, all list.next is not equals to null, all list.next is not equals to null, while list.next list L1 higher next is not equals to null or wow L2 whatever that guy did, I am simply doing the same actually. Not equals to null because I need to actually practice. I don't know much DSA. Or see, that will be beautiful. That was a very elegant code, but I didn't understand what he did with L1 or L2. I really didn't understand, so I'm not doing that. While L1 2 next is not null, or L2 the next is not null, or C is 1. I have not written that, but 1 is basically true for this for C. Okay, fine, beautiful, everything. Now what will we do? Just add. For example, 5 plus 2 is 7, 4 plus 6 is 0. Wait, 0. What will we do? This is pure math. This is something based on purely mathematics. Let's go. We need to simulate an adder. Okay. Okay, in sum. We'll have to actually separate it into two variables. Into in sum and into in. Okay, first of all, let's just think about L1. Okay, this is going to be fatal. This is going to be dangerous. This is going to be dangerous. What are we going to do if there is nothing? If this thing, if this isn't here, For example, 243 plus 342 plus 65. Only that much is there. We don't have 465. What will we do? We need to actually communicate the carry forward to 1, to the 1. Like we need to carry on. We need to actually carry on. Now what will we do? That guy was actually right. L1 and what? L1 and what? For example, there is something of a, like, in the end there is 9 in the end, like the end of a digit, there in the end of a number, like in the higher most significant, in the most significant digit, if there is 9 and somehow there carry forward comes of 1, if a carry over 1 comes over 9, and then we will have to add it. Consider that too. So we can't leave them aside, you know. So we can't leave them aside. We will, the more carries there are. Okay, let me just simply write it. The more carries there are, the more carries, or the more, not calories, the more carries, or the more numbers there are, we need to act, the more places we need to accommodate for. We need to accommodate. Okay, accommodate. Beautiful. So what is happening here? So L1 isn't equal to, so what is happening? L1's next isn't null, isn't null. Then only what will we do? Then what will we do? Then only we will try to be a bit vigilant. Isn't null, then we will add L1. Then add L1. Okay, then add L1. Okay, then add L1. Okay, beautiful. Actually, what does turning operator do? It just returns a value. It just does the nothing like the statement. It is the modification of a statement. It just returns a value. So we can do this. I think what we will be able to do is that in sum. So what will we do? We will add C. We will add C. No, not C, but L1 hyphen val. Beautiful. So L1 that next is not null. L1 next is not null. Okay, so understand this. If L1 next is not null, we'll have to add L1 val. But the problem is, what if there is only one number? What if there is only one number? We can do anything, but we will have to be vigilant. L1 dot next, like whatever is that, L1's next, if the next of L1 is not null, what will we do? If it is null, then I have nothing to say. But if it is not null, like the next is null, okay, the next is null, okay, but what about this? For example, we have 10 and we are in the ones, the 1, we are in 1 after crossing 0. So what are we doing here? Actually? So there is 1 and there is a list. So there is 1 and there is a list. No, not a list, just a linked list. So what are we doing? Everything seems to be very complicated. So what are we doing exactly? We need to think, we need to sharpen up our intuitions. So what are we doing basically? We need to think. Okay, so okay, what will happen if 1, 4 and 3. Okay, so let me just write it down. 1, 4, okay, and 3. We are getting these. Okay, so the arrow is from here. The arrow is from here and then goes to here. What will we be doing if something like this happens? That okay, so you have 4 and 3. We are taking business of these two individually. Okay, this will be determined individually, this will be determined individually, but we aren't getting anything in this. Where is the thing? We don't have anything. We don't have anything, so it will be treated as null. So what do we do? It will not consider, the operating system will not consider our opinions. So what will we do? What will we do? The list is null. If the list reference is null, wait, we need to check the code once again. In val, structure is not next. So thinking about this, if you think like L1 is going to be null, then you are on the right track. L1 is going to be null, and none of these sorts of nothing anything else. L1 and 12 will be done, otherwise we will just take 0. No worries, and then we would get a value. The return value is just a normal value. And what will happen? Just the same thing, just copy it, like literally copy it. Nothing hurts more than not copying. Beautiful. This is what we wanted. So now see if sum is greater than 10. Oh, don't do this mistake. Okay. We need to do something which can be done in multiple statements. Like it is actually because of making code more readable, but for the sake of complexity, what should we do? What should we do really? What should we do? Should we Nobody's coming here. Fine, I'm just okay with it. But what should we do? There are so many dislikes here. We need to add to this list. Anyway, just beautiful. This is just a fascinating problem. L1 isn't null. Do you realize this? L1 isn't null. And so, okay, we need to amp up sum if sum c equals to sum greater than 10, because in base 1 we only have, like seriously, in base 1, for example, f and f can be multiplied. For example, 15 and 15 we get 30, or in other words, we get f and f to get, like, what is the, tell me, like seriously, there are a whole lot of stuff regarding the n minus 1 numbers in base ends. For example, in base 16 we get f. F is one of the greatest, like F is a very legendary one, just like 9 or just like 7 in octal. Like these guys are legendary actually. What do they do? First of all, I would like to say that they just decrease by 1 and they just keep it a carry forward. What do they do then? Hear me out. So, my wild guess is that f and f gives us 1e, 1e, simply 1e. What is 1e? It should be probably 30. 1e 30, 1e 30, probably 1e 30. We need to find actually 1e 30, 1e 30. Okay, so for 60, 160, what is e? 60, 160, but what is e? Wait, this is literally, wait. On e, we get an f, like we get an f plus 1 plus e, which is the same as f. Like seriously, this is the same. For example, if we try to f plus f and then we get 1e, so 1 into 16, which means is what? 1 into 16, 1 into 16. What is 1 into 15? Like no, not exactly. What is 10 into 15? Like, no, not exactly. What is 10 into 15? 6. What is 15 exactly? We get what is 16. In base 16, 16 is basically 10. Okay, 16 is basically 10. So f plus f, we are just getting f plus f. And 1 into, so we need to prove that 1 into 16 plus e basically. 1 into 16 plus e is basically, wait, what is 1 into 16? We get f plus 1 plus e, f plus f, we get f plus f. I proved my point. I really proved my point. So what is 1e? 1e is basically 30. 15 plus 15 is basically 30. It should be like breathing air. Like it should be as simple as breathing air. 1e 1e is basically 30. It should be breathe air. I don't believe in undiluted, but I believe in breathing. Whatever it is, I genuinely believe in breathing as I breathing. Well, breathing breathing is very breathing is very important actually. Oh, beautiful. That is so beautiful. Wait. Sam is greater than 10. So we will get 1 for what is the maximum thing we can do. 9 plus 9 is actually 18. So n minus 1 in its base, we get n minus 1 plus n minus 1 antics as very weird. We find them as very weird because they are very weird indeed. So what is there out there? So what is 9 plus 9? 18. Maximum carry forward 1 possible in base 10. That is as simple as breathing air. Okay, not antidote is toxic, but still breathing air is better. Okay. This is a complex super philosophical piece. Okay, anyway, so what are we doing? Why did I even say that actually? So basically, what do we have actually? Int sum, okay, so beautiful, and C, okay, so beautiful. And what do we have after that? So in sum, we get the sum, and then we get the carry, and then we get what? Sum minus equals to C. That is so beautiful. That is so beautiful. That's so beautiful. Not so beautiful. And what will we do? We will simply. Oh wait, we have L3. Ha ha ha! We have L3. Ah, okay. So we need to traverse. Traverse. We need to traverse. Structurally node. Mm-hmm. PTR equals to L3. Okay, beautiful. Now what will we do? So let's put this and okay. So we have got okay. So let me keep it okay. So what do we have here? So this is it is as simple as breathing in. So sum C, sum minus equals to C. So what do we do now? We will just add. But what if what if okay? So what if so what if but if what if we need to add the oh it is always need to add it. So what do we do? 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 We try to do something else. So what do we do? What do we do? PTR PTR's valve will always be something weird. It will contain something eccentric. We will give it the sum. We will give it its sum to 8 and then we will go into full frenzy mode. We will okay. So PTR will be PTR dot next. This is what I mean as meant as being frenzy. Like math r slash math means is okay. L1 is equals to L1. This is very this is very dangerous. First of all, this is going to be dangerous. This is going to be dangerous actually. First of all, create a node. Just create a node for our precious for the precious PTR. Create a node for God's sake. Please create a node. Please create a node. Just create a node. How to create a node? Do we know how to create a node? We don't know how to create a node. Oh my god, we'll have to make something new. New. Struct list node star new is equals to malloc size of. Okay, so beautiful. This is beautiful. This is called genuine beauty. So what do we do now? struct listener. New equals to malloc size of list struct listener. So we have something new. New is not a keyword. We are saved. We are really saved from this. Ah, okay. So malloc size of struct listener. So malloc size of struct listener. Malloc size of struct listener. Malloc size of struct listener. What is malloc size of struct listener? Okay, well, what do we do after that? 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 Okay, okay, okay. We need to tone down ourselves a little bit. What do we do after that? Malloc size of struct listener. Malloc size of struct listener. Malloc size of struct listener. So we need to actually, we have made a new node actually. Understand the fact that we have made a new node. And we need to link this new node, like, so we need to connect the address of this new node. This is the address. We have stored the address here, so it is beautiful. We have done something beautiful, but we need to inform that ptr next is actually new, and ptr is literally ptr.next. We have done that. If if everything is fine, a L1 dot L1 next isn't null, then what will we do? We will try to do something. L1 equals to L1 dot next. Okay, same thing, exactly the same thing for L2, but we don't need to actually like do everything in functions. Okay, L2 cannot do. Beautiful. Ha, really we have done this part of the problem actually. And what if we have edge cases? Let's think about that. What if we have edge cases? I think we need to run the code. Mm, so what will be written? Finally, what will be written? Mm, I think we should. I think we should made it far sooner. We have done something problematic. Mm, I think we have far sooner. Um, Ah, what to tell you? This is not a doubly linked list, so don't exactly, can't exactly do what we are. I am thinking of doing. Like, how can I keep this? Like, this should be PTR. Okay, PTR is running errands for us, but L3. Okay, L3. We are making this PTR as L3 now. Hmm. We need to assign that value. We need to create a new one. We need to create a new one. Okay. PTR. Um, Next will be null. We need to create it. We need to create it, and it will be null. And so PTR val will be 0. There are no exceptions to this. We are actually creating something like this. So there aren't any exceptions to this. So while it is not null, so sum will be L1 not equals to null. L2 not equals to null. Okay. L1 not equals to null. So sum is redundant. That is okay, but I'm mostly concerned with the data structure actually. PTR val is sum. Beautiful. Now what we have new malloc size of struct list node and PTR next new. PTR equals to PTR. PTR next will be new. We'll have new PTR next, then okay. Um, hmm, uh, I think we should tone ourselves down a little bit. Uh, Actually not, but actually, I have no idea what will happen. I haven't even line 32. I understood. Return L3. I am just simply scared of returning it. What will happen? I have no idea. I have absolutely no idea what will happen. Runtime error. Member access within misaligned address for tie struct list node which requires 8-byte alignment. Wow. Ah. Line 70, char 15, runtime error. Member access within struct list node. What is struct list node? Um, this would actually do anything, but what is happening actually? Uh, char 15 was 8-byte alignment. Some segmentation fault. Runtime error. Char 15. A type struct list node. Member access within misaligned address. Member access. What is actually happening? Huh? Huh? Member access. What? What in the world is this member access? Member access. Member access. Um. Member access within misaligned address. Member access. Runtime error. Oh, this is a runtime error. Member access within misaligned address for type struct list node. Plus 8-byte alignment. 8-byte alignment. Actually, it makes sense. Struct list node for keeping the pointer and the okay, okay. Ah, ah. If L3 goes to null. Let really just return an error message. Return 1. Like what to do? Like seriously do something which won't error. Printf error. I just don't. I don't have any idea. What to do. I think I need ChatGPT for this. This is so weird. Recursion. Really recursion? I don't think that this is under recursion. Uh, I guess we have to. Not sure. Makes in the last element isn't set to null. Okay, we need to create. While creating it, we need to make it as null. Stock style is not new. Okay. We need to make it PTR to next. But PTR next should also be null now. So that is actually I didn't hear heard of. I didn't know about this error before. Okay, that is quite weird actually. I really didn't know about this error. PTR val will be what? PTR val will be 0. I think we need to keep this whole thing separate actually on whatever is going on. This is also separate. Keep this separate actually. What is happening? Mm, what is happening? So 2 plus 5 is 7. Beautiful. 6 plus 4 is 9. How can it be 9? What? Why? Guys, why? Sum minus equal to C is actually quite genius, I guess. Ah, wait. Why is the we can't use that 0 actually. The end. Otherwise, the code would have run fine. If we don't need anything else, then we don't need anything else. If now, we can't actually use that 798. 7 now because the carry forward is not actually working the way it's intended. Sum minus equals to C can't be the case. Sum minus equals to 10 should be the case. I understood. If an equal statement doesn't actually hurt, it really doesn't hurt. C equals to if it has carry, then C. Whatever we will do, sum equals to, if sum is greater than 10, sum is greater than equals to 10, then what will we do? We will simply subtract minus 10, or we will subtract 0. As simple as that. Now we need to deal with this, the last thing, that 0. How will we deal with it? How will we deal with it? How can we deal with it? If something, if there is a carry, or if say these same conditions will be applied. Seriously, these same conditions will be applied. But what? Wait, what? Oh. While L1 dot next is not equals to null, L2 dot next is not equals to null, or C, we will make this. Okay, I think I figured it out how they are making this. If someone is making stuff like this, then I think I know how to do this. Control X and then Control V. This is the sheer beauty of all it. Now PTR, we don't need to even say that it is based on L3. We don't need to say that. L3's next will already be assigned to it. We just need to do a malloc and then let the company know that I think the while loop is better actually for this. I think a dual loop is better for this. Oh wow, I think a dual loop is better for this one. But now I am confused. At least we will have to do it once, not PTR. Now we know that we will have to at least do it once, only once. We will be able to manage that. Here's the thing. Literally, here's the thing. Do this. Nobody will be able to stop you. Then you are free to just free this new thing. Okay. Okay. But we will have to do this actually quite often. And then what will we do? And then we will just keep on doing stuff like this. Keep on doing stuff like this. Meant to get the next one and the next one and the next one. The first one, at least we can do something unique. Malloc size of struct list. L3 malloc size of struct list. Yeah, simply as L3, right? we have nothing to say about. Is usually considered black. Ah, yes. I think I need to. No. We need to win the pointer which can locate. Will be also need an pointer which can locate, but we also need something new. Now, if everything's fine, then only we will be doing that. Nothing is fine, then we will not consider doing that. See everybody out there. It's a very risky one actually. Control X. Else if there is a carry forward, then we will be escalating that. But L1, L1. We still have a carry forward, then we are escalating that. Now I don't want to write the same condition in it. What to do? I don't want to repeat code because I'm pretty allergic to repeating code. How to do everything? Yes, next. At least the first one should have somewhat of a basis. And this ensures that we will only do in the last one. But this doesn't ensure that if everything is null or everything is problematic, then if we are about to get out of the loop, we can simply wait a minute, what? We can simply free PTR. Wait. Free PTR. We can simply free PTR. PTR and we can also free new. Because these are just like you can't go back. Wow, beautiful. This is so beautiful. Free new. New undeclared. Oh my goodness. New undeclared. We'll have to free new at this instance. New. We don't need anything actually from new. Address sanitizer. What? Heap use after free on address. Free on address. Okay. Oh, we are. Oh, the address is being freed, not the variable. Then, wait. Let me just see what happened. Oh, we are the problem here. 974 now. First of all. Nah, I think we need to eradicate from the root signal. Now, what do we do? Next is new. Next is new. Ptr dot next is new. If it has nothing, then we can do something. But it has a lot of things. Why is the heap being used actually? You know? Actually, in the last address, we can't. It is not a W linked list. We can't go back and change it actually. Oh, it can't be done. So how can we that this is a problem at all? Ah, if next is not now. If next of next is not null, if next of next is not null, hmm, like that. L1 next isn't null. No, if literally L1 or next isn't basically null, or L2 dot next isn't basically null. Basically, this just irks me a lot. Or there is C. Then we will make this whole thing there and only then. Hmm. There's something of a. Hmm. I know it. What if I change this one? Will somehow command me on this value? I understood. I finally understood it. 92. What if it's actually 92? What if it has 9? TL accident. Hi. Ooh, this is just so beautiful. I have just no way to answer this. Uh, mhm. That is just so dumbfounded lazy. What am I doing wrong here? Uh, huh? I have no idea what well, I really I submitted as a failure. I couldn't do it actually. Okay. Well, I could wasn't able to do the first few problems either. So, the previous one, the previous live stream, one I did in the previous one, I didn't do that actually. So I guess this counts as a fail. Um, Things like that will keep on happening. Okay. Mm, I'm still learning actually DSA. I'm still learning this. I just don't know a lot of stuff. I know, but only in paper. I haven't practiced it much, you know. So I guess goodbye for wasting your time.